Welcome, students, to Radian Measure Part 2. And to start us off, I've drawn the special triangles here, albeit with degrees. And what you want to really get to know now is, well, what would these angles be in radians? Now, last time I mentioned briefly what they were, but just to refresh your memory, 30 degrees is the equivalent of pi over 6. 60 degrees is the equivalent of pi over 3. So you really want to get to know these radian measures. And 45 degrees is the equivalent in radians of pi over 4. So you want to memorize those because we're going to start to use them quite a bit. So let's do an example here. And in this example, we're going to figure out what is the cosine of 4 pi over 3, and this has to be an exact answer. All right. So when you're talking exact, you pretty much know you're going to deal with the special triangles. So I like to get a picture. It doesn't matter what we're doing. I just find if you can get a picture, it just kind of frames in what you're doing. I'm going to draw a grid here, and on that grid I'm going to try to locate where is 4 pi over 3. Now it is helpful to know that 90 degrees is pi by 2, okay? Or if you are working in approximations, it's a little bit more than half of, it's half of pi, and pi is a little more than 3, so this is something around 1.6. So I like to have that number in the back of my mind. Pi is 180 degrees over here, which is a little bit more than 3. And then over here we have, this is actually 1.5 pi's. And then once you get to here, you've gone 360 degrees, or in radians, 2 pi. All right, so that kind of frames it in a little bit. Now I got to look at this. Where is 4/3 pi? Well, that's a little bit more than pi, right? So it's more than 1 pi. So I'm going to draw my terminal arm down here. And now I'm going to try and figure out what my reference angle is, because the strategy we like to use is figure out in our little triangle what reference angle we're working with. Okay, so this, remember, all of this is pi to get me to there. So how much more do I have to go to get to 4/3 pi? Well, looks like I've gone an extra third, right? This would have been 3/3, or a complete pi, and then I've gone an extra third. So now I look at this and I go, oh my goodness, that's just like my special triangle, which I've erased. But anyway, let's just redraw it. And I'll orient it the same way as I've got drawn over there. Okay, so here's my special triangle. And this is the pi by 3, which is like 60 degrees. There's my 90. So that means that it's got a hypotenuse of 2. The shortest side is 1, and over here would be root 3. All right, so now I'm looking for the cosine of this thing. Well, that would be adjacent, over hypotenuse. So I know I'm talking numerically it's 1/2. The only question is, should it be positive or negative? Well, look at the quadrant we're in. If this is cosine in this quadrant, it's going to be negative. So there's my answer. Nothing to it. All right, let's do another one of those because they are exciting and fun. Next one is going to be, we're going to try to find an exact value of the secant of 11 pi over 6. Let's go, oh man. All right, let's get a picture going here. Okay, so where's our terminal arm? Well, let's have a look. You know, this is so close to being 2 pi. You know, 2 pi, if I were to write it with a denominator of 6, it would be 12 pi over 6. So I'm thinking, you know, we're just shy of that. We're at 11/6, so we're just going to be a little bit under, something like that. So what does that make my reference angle over here? Well, what's the difference between 11/6 pi and 12/6? I'd have to go with it's 1/6 shy. Okay, that's my reference angle, and this is my special triangle. So if I draw a quick version of it over here, all right, not the neatest looking little triangle, but anyway, this angle here is the pi by 6 angle, which means, as far as my special triangle goes, this is like 30 degrees. This is the 30-degree angle. So that means this would be the 1 across from it, the shortest side, and then I'd have a root 3 across there. Now this time I'm looking for the secant of this thing. Secant is the reciprocal of cosine. So instead of root 3 over 2, it's got to be 2 over root 3. And did somebody say cosine? My goodness, the cast rule says cosine and its reciprocal are kept positive in this quadrant. So guess what? There's our answer. So I think on that very positive note, I'm going to stop right now, and we're going to pick it up with some more exciting examples in a bit.